Page 282. This, and again, this I started this yesterday. It says solve the logarithmic equations. All right, now, there's two types of questions. I said this to you yesterday, I showed you on the board yesterday. One is when the exponent is in, the variable is the exponent, and you have to change to logarithms. The second is when the variable is within the logarithm, and we have to change to exponential. So what we want to do then is we want to get them all to one side. We want to get the logs to one side. Okay? And then we're going to make them one single logarithm. All right? So here's an example. Log 5x plus 1 to the base 4 minus log x plus 17 to the base 4 is equal to 0. Okay, so I just transferred it over to one side. First step. Okay, now I'm going to write this as a single logarithm. Because it's a subtract now, what do I do with the numbers in the variables right here, the terms right there? What do I do? No. No?
Can't you just like exclude the log base 4?
Oh, not yet.
You can't just deal with powers?
No. What's the rule?
Divide.
Divide. Yes. So what do I do? Okay. I go log base 4. Draw my line. Right? If it's a positive, it goes on top. If it's a negative, it goes. If it's a subtract, it goes on the bottom. Okay? And that's equal to 0. That's simple enough. That's just rule number 2 from your logarithms. If you subtract, you divide. Fair enough? Now think about it in terms of your exponent rules. When you have x to the 4th over x squared, what do you do with the, so you're dividing, and what do you do with the exponents? You subtract them. So that's where this log rule comes from, right? Now, once I have a single logarithm, I can transfer it into an exponential function now. So let's do that. So how do I change this to an exponential function? I take my base and what do I do with it? Put it to the other side and raise that as my exponent. 4 to the power 0. And then that's equal to 5x plus 1 over x plus 17. Okay? And that is that's the primary and most important log rule, operation that you're going to do is change from a logarithm to an exponential to logarithm. So at this point now, what's 4 to the 0? 1. Multiply that up. I get 5x plus 1 equals x plus 17. 4x equals 16, x is equal to 4. And then the one difference that you are going to have to do, you do want to place that value into each of those. Remember, you cannot have the log of a negative number. And essentially, that's all you're looking for. So when I put the 4 in here, that's 5 times 4, which is 20. 20 plus 1, 21. We're okay. 4 plus 17, also 21. Well, I want you to think about this for 1 second here. Right? The value here minus the value here has to equal 0, correct? Right? So 4 was the obvious answer here. Does it work for any other number? If I put 5 in, will it work? 5 times 5 is, plus 1 is, and then 5 plus 17 is. So that can't work, right? Okay, so that's what we have to just establish. All right, we want to look at it. We want to make sure that we haven't missed anything. This is another one that you're going to see a bunch of extraneous roots. So roots that won't work. So what is it that we're looking for? If I put this value in and it becomes a negative number, and then it doesn't work, cancel. So
could we, like, is it always, if it equals 0, then we could just take the exponents and make them equal each other, right?
The exponents and, no. No, no, you can't do it in that situation, right?
I thought we could just shortcut to where, like, just did what did.
Okay, so here's what we got, alright, so let's go back. Yeah, you're absolutely right, okay? But it's not worded the way you want it, just a sec, Cody, and I'll come to your question. Okay, you didn't word it the right way, but you were absolutely right. What you meant is correct. What could I have done here? Well, I started like this, right? I started like this, okay? Well, what do I know? In order for this to equal that, if I've got the same base, then that means that that value and that value have to equal each other, correct? Is that not right? And it's very similar to exactly what you said. All right? What if I were to do, and don't do this ever. Don't do this ever, but I'm going to show you this. Okay? If you raise that up, you'd have this. And you raise that up, you'd have this. This is terrible math. Don't do it. Okay? Well, that's essentially what it looks like. So then what does that mean? That has to equal that if your bases are the same. Which is exactly what Carlton is saying here. Okay? But it's not the exponents that we're talking about. It's the value that's in the logarithm. Okay? So that is the way to do that question. Now, why? Why then did I go through all of this? Because as the questions get more complicated, this is the method that's going to help you out. Okay? There was a simple method to do, but this is going to help you out. So let's look at the next question. We'll look at the easy way and we'll look at the hard way.
So if the bases are the same, you can more or less do that, you just get those values to equal each other?
Yes. But that's only if there is no other value in it. Okay, so the difference, let's look at number 2 and I'll explain your answer. Okay, so I have the log of 5x. What's the base here? 10, that's right. So minus log x minus 1, and that's equal to 1. The difference being, Emily, is this right here. If it was equal to 0 and I could just have them on both sides, then absolutely you can do that. Okay? But that value changes everything for us. So now I'm going to use the same method that I actually used before. Alright? And that is this. Log of 5x over x minus 1. This big square bracket included at all times. Okay? Because if you're actually multiplying these, it'll take the log of the first term and not the second term, where it should be the log of the multiplication of the two. Okay, so I'll show you an example. The next example, I believe, is in an add. Yeah, so I'll show it to you in the next example. But include these square brackets, okay, as part of your work in progress. All right, so at this point, what do I do next now that I have a single log? Yeah, what do we call that? What are we going to do to it? Yeah, we're going to change it to exponential, right? So what is my base here again? 10. So I've got 5x over x minus 1 is equal to 10 to the 1. Right? Multiply x minus 1 up, I get 5x is equal to 10x minus 10. 10 is equal to 5x, x is equal to 2. Okay, so far? Any questions so far? Okay. All right, I want to show you the proof for this. Okay, I want to show you the proof because this one is actually interesting. Not that none of the other ones aren't interesting. Okay, put 2 in here. What do I get? Log 10. Subtract log. Put 2 in here. What do I get? 1 equals 1. What's the log of 10? 10 to the base 10, right? Yeah, so it's 1. Okay? So what does that mean that this has to be in order for this to equal 1? What does it have to be? 0? Has to be, right? This has to be 0. Because how else can I get 1 subtract what is going to give me 1? So now, your question to me is, well, is the log of 1 0? Is the log of 1 0? Okay? Anybody want to? Yeah? Nah?
Yeah.
Not sure?
I hope so.
Okay, so here's what happens. I'm going to use, and I believe it was Carlton that said this yesterday too. You put the X on the other side, right, Carlton? Yeah, good. Okay, so here's what happens. All right, I put X over here. So I'm going to let log 1 equal X, and I want to solve for the X. But in order to solve for the X, I need to get rid of the log. So how do I get rid of the log? Change it to exponential. 1 equals 10 to the X. What does X have to be? It has to be 0, right? Any value of the log of 1, regardless of the base, is always going to equal 0. Okay? So that was a rule that we haven't looked at yet. We looked at the log of a number to the same base, right? That was equal to 1, but we never did this. We never did this. So now we proved it to ourselves that then, therefore, X has to equal 0. So if you have the log of 1, whether the base is 4, 5, 6, 7, 8, it doesn't matter. It's still going to have to be equal to 0. Make sense? Okay, so that's last bit of interesting info. Okay, so here's why I use big brackets. All right, look at that third question then. Now I'm skipping a step. What's the base? 6? Okay. So when I'm adding them, what does my log rule say to do? Multiply. So now I have x minus 3 times x plus 6. This is the reason that I do the big brackets. Okay? The reason I do the square brackets is for this multiplication part right here. Alright? Because if I write it out and I don't use these big square brackets, what it looks like to the person correcting it or the person marking it is that you're going to take the log of this value to the base 6 first and then multiply it by x plus 6. And that's very similar to what we don't want to do in trig when we have sine alpha plus beta. It's not log times all of that. It's an operation. So you have to take the log of that times that first to the base 6. Okay? So at this point, what do I do next? Not yet. What do I do? Exponential first. Okay, so I've got x minus 3, x plus 6 equals 6 squared, which is 36. 6 to the power of 2. Right? And then you've got x squared minus plus 3x, thank you, minus 18 minus 54 is equal to 0. Right? Minus 3 times 6 is minus 18, and I gotta subtract 36 to get it to that side. I got x plus 9x minus 6 equals 0. X is equal to minus 9 and plus 6. Okay? So now when I stick this in here, I'm gonna end up with a negative value, right? So this guy can't work for sure. And then it's up to that guy. 6 subtract 3, sure, that's 3. 6 add 6 is 12, we're okay. Right? Okay, now you're not going to check these on your calculator because this is all non-calculator work. We just did this without a calculator. Okay? This right here, what you're looking at, is the exact style of question that you're going to see in that first 11 questions on the exam. Or you'll get this one in the last 7 or 8 questions, because it is a non-calculator question. So this is one of the questions. So what does this one have that's so important to you? It has you changing to a single logarithm, so getting all your logs on one side, changing to a single logarithm, and then changing that into an exponential. And that's how you get the variable away from the log. The next question I'm going to show you is the opposite. We're going to take the exponential and change it to logarithm. So this is the one I was showing you yesterday. This is the guy I want you to work on today. I'm going to do a little bit shorter version of it. 3 to the 2x is equal to 7 to the x plus 1. All right. So now, remember, our objective is to not have the exponent as the variable. This is the longest question you're probably going to do in all of grade 12, next to an identity. Okay, this is the one that has all of the work to it, and it just takes time. It's not difficult, but there is a lot of work, and there is areas you can make mistakes. So we want to follow along. So the first thing I look at this, all right, I've got a base here of 3 and a base here of 7. So because the bases are different, and I can't change them to make them the same base, that's what you always hope. You get the question on the exam in which that maybe is a 9, and you can change it to 3 squared. And then it's easy. Right? But I can't. So what am I going to do? I'm going to take the log of both sides. So I've got the log of 3 to the 2x equals log 7 to the x plus 1. Okay so far? Just taking the log of both sides. Now that I have the logs written like this, my objective is to get the variable out of the exponent. At this point, can I do that? Can I move the variable so that it's no longer an exponent? Sure, why not? What's the third rule? Take this guy, move him to the front. Take this guy, move him to the front. Okay, that's the third rule. It's on your formula sheet.
Did you do that yesterday?
Yep. So I have 2x log 3 is equal to x plus 1 log 7. So far I've used 2. Well, 1 rule, really. I haven't used 2 rules, I only used 1. I took the log of both sides because I want the bases to be the same. So what have I changed the bases to in this question? 10. And then a second thing I want to do is get the exponents out, or the variables out of the exponents. So then I moved them to the front. Okay, so far? Now it's algebra. Okay? So this is 2x log 3. I'm going to leave that. Is equal to, I'm going to multiply that through. X log 7 plus log 7. Okay, so I multiplied through the brackets. Anybody have any idea what my next step should be? What should I do next? What have I always done in the past to solve for a variable?
One side.
What do you got?
Put it all to one side.
Put it all to one side. Okay, get the variables to one side. If I'm looking at factoring and I'm looking at different, like if I have x squares and stuff like that, right, then I would get it equal to 0, correct? But all I've ever been taught from grade 9 on is get the variable to the same side. So let's put the variable on the same side. So to do that, I'm going to subtract x log 7 over to here. Make sense to everybody? So then I have the x on the same side. So now I have, I'm just going to change the color here, 2x log 3 minus x log 7, and that is equal to log 7 over here. Yes, Carlton?
Where does the x come from? Like from the x log 7?
X plus 1.
I'm timing x times that and 1 times that.
Oh yeah, yeah.
Okay? Is that right now? Yes, Brian?
That's right.
You got it now? Okay? Everybody's okay to this point? All right. What's the next thing I got to do? What's my overall goal in the end when coming to solving for variables? What is it that I need to do? What do you got to do? Get x alone. Awesome. Absolutely. Isolate x. What do you suppose I do right here? Yes. Absolutely. Okay? Because I have two x's, and these are not the same. I can't add them together, right? If it was 2x plus 1x, I would add them and I get 3x, but they're not. These are different values. Okay? Now at this point, you could use your calculator. Don't. Alright? But you could. If you were unsure of yourself, I'd go 2 times log 3 times x, or well, it would give me a value, x, and then I subtract log 7x. And then I would get that. But what I want to do here is I'm going to factor it out. Like you said, I like that. So I take the x out. What am I left with if I take x away from here? 2 log 3. What am I left with if I take the x away from there? Log 7. Now I have one more step and I'm done. One more step. How do I get x by itself? Divide by what? Yes, it is. I divide by 2 log 3 minus log 7. So let's move it over to this side. Log 7. Okay. 2 log 3 minus log 7. And put that in brackets. There's 3.5 out of 4 marks on your exam. The last half a mark is to actually use your calculator properly. So if you're in a bind on the exam, this is an example of one of the first 3 questions you'll get on the exam usually. And then it'll be a calculator question. It'll have a little calculator in it. You're going to need the calculator for it. You'll put it at the top of the page. But if you can get this far, you've actually got it 100% correct. But then they're asking you to calculate it. So right now, put that into your calculator and make sure you can get it. And go to a minimum of 3 decimal places. Use brackets. Brian, go ahead.
7.7.
3 decimal places, Brian.
7.7. 7.743.
Anybody else get that? Anybody not get it? Everybody's good? Okay. Is Brian around that correctly? How on the exam do I make sure that if I'm not real confident in my rounding, to make sure I get it correct, put 1 more decimal place. Okay? And then you don't have to round it. You can't make a mistake on it. Alright, fair enough? Okay, so let's have a look at this question again. And let's actually compare it to the last question, because this question here started with 2 logs. And then we put it and simplified it so that we had 1 single logarithm. And then once we had 1 single logarithm, we changed that into an exponential function. And got rid of it. This guy starts as an exponential function, in which the variable is in the exponent. So it's hard to do. So what do? I take the log of both sides. Take the log of both sides. Then I take the exponents and move them to the front, because that's how I get it away from being an exponential function. Alright? I isolated, I simplified it first, then I moved the x's to one side, and then at that point I factored an x out. You're going to do this almost every time. Factor an x out. Okay? That's just the way it works. Now, any questions about this? I have one more thing I want to just point out. Any questions about this point? These 2 questions right here are guaranteed exam questions. Guaranteed. 100% on the exam. So you want to make sure that these are the guys that we want to do well. Okay, so I got 2 things to point out to you. I said 1, I got 2. First one is this. You can use natural logs as well. And it works the exact same way. Natural log is that ln, which is actually log base e. So instead of changing it to base 10, I'm going to change it to base e by using natural log. And everything works the same. So wherever you see log here, you just put ln in here. Now why would I do that? The reason I do that is if the base value or the exponent, if the question had started with an e somewhere in here, then I might use natural log e. Because what is the natural log of e? What is this equal to? What is the natural log of e equal to? What is natural log again? What did I just say it was? Why?
Because it's to the base e.
Yes. Very good. That is 1. Why? Because remember I said we either change it to base 10 or we change it to base e. If I use natural log, that's base e. So the log of e to the base e is 1. So that's why you do that. Okay? So if there's an e anywhere in the question, there I would do that. Second, and this is for your test coming up next week. Okay? The second thing you want to do is you can graph this. Graph y1 equals 3 to the 2x. Graph y2 is equal to 7 to the x plus 1, and find their intersection point. And there's your solution. Okay? On the exam, that or that in that particular question will be okay. You can graph it. So you would sketch your graph of whatever's on your screen. Basically, you're taking a screenshot of it, putting it on paper, and you could show your answer. So let's try this right now. Graph y1 equals 3 to the 2x. Make sure your stat plots are off because you were using them in apply. Okay?
Would you put your power